So derivatives. So let's see the definition of derivatives. Suppose you have a function y is equal to f of x is a function of x. Suppose I change the value of y. Okay, the value of x, sorry, value of x is changed by a small value, changed or incremented. You can use any words, change or increment, and by a small value delta x. So basically what is happening is x becomes x plus delta x. Like for example, x was 2, then x becomes 2.002 or 001, something like that, by a very small value. Then the value of y also changes. So corresponding change in value of y can be considered as y plus delta y. So the change is delta y, and so its value becomes y plus delta y. So the above equation 1, we will be able to write it as y plus delta y is equal to f of x plus delta x. That is due to the change in values of x by a small increment delta x, the value of y is incremented or changed to del y plus delta y. Now, there is no reason that delta y and delta x have to be positive only. They can be negative. It basically means change. So, it could be a change in a positive direction, change in a negative direction. So, I'll consider this as equation 2. Now, if I do 2 minus 1, I get delta y is equal to f of x plus delta x minus f of x, because that y and y cancels. Now, if I divide this equation by delta x, okay, so remember what is this delta y representing? Delta y, this entire equation, delta y, which is equal to f of x plus delta x minus f of x, represents change in value of y. Change in value of y. That's what it is representing. So if I divide it by delta x, I get delta y by delta x is equal to f of x plus delta x minus f of x divided by delta x. Now this will be called as the relative change in y with respect to its original value, right, or with respect to x. So it's a relative change in y with respect, I won't use the word relative also, so change in y with respect to x. So it's delta y by delta x is equal to f of x plus delta x minus f of x upon delta x. Now this change that I have made, delta x, this change that I have formed, I want this delta x to be very small. Okay, this delta x, the change that I'm making in the value of x, I want this change to be very small, and if it has to be very small, then this delta x should tend to 0. So if I take it as tending towards 0 and take its limits, I'll get limit delta x tends to 0, delta y by delta x is equal to limit as delta x tends to 0, f of x plus delta x minus f of x upon delta x. Okay, so this is my equation 3. Now if the limit on right hand side, okay, that is this limit, okay, the limit on right hand side exists and is finite. Remember, you can have limits which are infinite in existence, and there are limits like 1 upon x as x tends to 0, which does not exist only. So if the limit on RHS exists and is equal and is finite, then we call it as derivative of y with respect to x, and we write it as limit as delta x tends to 0, delta y by delta x is equal to dy by dx, okay, which is also equal to this value. So basically derivative of y with respect to x means its limit delta y by delta x, that is the change in y with respect to change in x. As x, the change in x has to be very small, and it is given by limit of f of x plus delta x minus f of x upon delta x as delta x tends to 0. Okay, so this is the definition of derivatives. This is called as the finding the derivatives, finding derivatives using definition. Okay, you may say by primitive method, and the third would be from the first principles. So whenever the question comes, find the derivative of the following using the first principles, we are supposed to use this formula that's there in the box. Okay, now to make things easy, we may use, instead of delta x tends to 0, we may use h. And so if we use h, the same thing can be written without loss of generality. We can write dy by dx is equal to limit as h tends to 0 f of x plus h minus f of x upon h. Okay? So with this we can solve now few problems. So first one I'll solve is find derivative of y is equal to x from first principles. Okay, so it's very simple. Okay, we have to use the definition. जो definition था वो use करना है. So y is equal to f of x. Let y equal to f of x is equal to x. Therefore f of x plus h will be equal to x plus h, and therefore by definition or by first principles, d by dx of y or dy by dx is equal to limit as h tends to 0 f of x plus h minus f of x upon h, which is equal to limit as h tends to 0 x plus h minus x upon h, which is equal to limit as h tends to 0 of h upon h. So h and h cancels because h is not equal to 0, and so this limit of 1 as h tends to 0 is 1, and so we get a first result d by dx of 1, d by dx of x is 1, so d by dx of x is equal to 1. That's the first result we get. Okay, we can find one more result immediately, and that is of f of x is a constant function c. Then in that case f of x plus h is also constant, and you will have limit as h tends to 0 of f of x plus h minus f of x upon h to be equal to limit as h tends to 0, and this will be c minus c upon h, which is equal to limit as h tends to 0 of 0, which is equal to 0. So the derivative of a constant is 0. Constant is equal to 0. Whereas limit of a constant is constant, but the derivative of a constant is 0. ठीक है? So the next one, let's find f of x raised to n. Y is equal to f of x is equal to x raised to n. So f of x plus h is going to be x plus h raised to n. Therefore, by first principles, dy by dx is equal to limit as h tends to 0 f of x plus h minus f of x upon h, which is equal to limit as h tends to 0 x plus h raised to n minus f of x is x raised to n divided by h, which is equal to limit as h tends to 0. And if I use binomial theorem, I'll get this as nc0 x raised to n plus nc1 x raised to n minus 1 h plus nc2 x raised to n minus 2 h square, so on till you get ncn h raised to n minus x raised to n divided by h, which is equal to limit as h tends to 0. nc0 is 1, so it's x raised to n. nc1 is n, so it's x raised to n minus 1 into h plus nc2, and this is x raised to n minus 2 h square, and so on till you get ncn h raised to n minus x raised to n divided by h. So this x raised to n and x raised to n cancels. Now h is there in every term. Every term that you see over here, it's h, then h square. After this you'll have h cube, h raised to 4, till you finally come to h raised to n. So I can take h common and I'll have limit as h tends to 0 h into nx raised to n minus 1 plus nc2 x raised to n minus 2 h plus nc3 x raised to n minus 3 h square, so on till you get ncn h raised to n minus 1 divided by h. Okay, so this h and h cancels, the reason being h is not equal to 0. Now I'll take the limits, and this will be, there is no h over here, so this part is a constant term as far as h is concerned. In terms of h, it is a constant term. That nx raised to n minus 1 is like a constant, because what is tending towards 0 is h, so it doesn't have the term h, so it's like a constant. Limit of a constant is constant, so it will be nx raised to n minus 1. This will be nc2 x raised to n minus 2, and there is one h, so it is into 0 plus nc3 x raised to n minus 3 0 square plus so on till you get ncn 0 raised to n minus 1. So all other terms, this all of these terms are 0, and what you get is nx raised to n minus n. So this is equal to nx raised to n minus 1. So d by dx of x raised to n is this. Okay, so that's the third formula, right? So you can find formulas of this type anyhow, कि जितना मांगते हो उतना ढूंढ सकते हैं. So I'll not find everything, but I'll go towards trigonometric part, and let's do those problems. Fourth, and that is y is equal to sine x, and you have to find the derivative of sine x with respect to x. So you will have, if y is equal to sine x, I'll say let f of x, or y equal to f of x, is equal to sine x, and so therefore f of x plus h is equal to sine of x plus h. And so therefore by first principles, you will have dy by dx is equal to limit as h tends to 0 f of x plus h minus f of x divided by h. which is equal to, so dy by dx is equal to limit as h tends to 0 sine of x plus h minus sine x divided by h, which is equal to, we can expand it or you can use the formula sin c minus sin d. You can, but उसमें ज़्यादा कट भी हो सकता है. Anyhow you can solve this problem, you can expand it also. We have been doing the problems by using sin c minus sin d. So one problem I'll do by expanding. So this is sine of a plus b, a minus b is sine cos cos sine. So it's sin x cos h plus cos x sin h minus sin x divided by h. So this is equal to limit as h tends to 0. This is sin x cos h minus sin x upon h. Is that correct what I'm doing? Yeah, okay, it's correct. Plus cos x into sin h upon h, which is equal to limit as h tends to 0. Sin x can be taken common. What you're left with is cos h minus 1 upon h. And we know this kind of limit. It is 1 minus cos h upon h square, that gives us 1. So what I'll do is I'll make this as h square and I'll multiply this by h plus limit as h tends to 0 cos x into sin h upon h. So this is equal to, sin x is a constant, so this is going to be sin x, and this limit we know always comes as half. But when it is 1 minus cos x, when it is 1 minus cos x, then we can write it as 2 sin square x by 2 divided by x square, and then solve, and this answer comes as half. But this is opposite right now, cos h minus 1, so this answer will be minus half, and this is h tends to 0, so it is into 0, plus cos x is a constant, so it will be cos x, and sin h upon h will be 1, so it's 1. So the answer happens to be cos x. And so we get the fourth formula, d by dx of sin x is equal to cos x. Okay? So you can derive anything like this. So cos x I won't derive now because that you can do, and probably it must be done in the book also. Already solved किया रहेगा वो लोगों ने. So I won't go into cos x. Right? So let me just check. They have done, for many problems they have done. Okay, they have done that. Okay, so I'll explain one more, and that is I'll take sin x. Yeah, they have done cos x, so I'll take tan x. Okay, so I'll take the alternate ones, sin x, tan x, and sec x. You can do the other work. Okay, so in this case, now this is the fourth one, that's a result. So now fifth one, let y equal to f of x is equal to tan x. Okay, so therefore dy by dx by first principles will be limit as h tends to 0 f of x plus h minus f of x upon h, which is equal to limit as h tends to 0 tan of x plus h minus tan x upon h, which is equal to limit as h tends to 0 sine of x plus h upon cos of x plus h minus sin x upon cos x upon h. which is equal to limit as h tends to 0, and this is sine x plus h cos x minus cos x plus h sine x, and divided by cos of x plus h into cos x divided by h, which is equal to limit as h tends to 0, and this is sine a cos b minus cos a sine b, so it's sine of a minus b, so it is sine of x plus h minus x divided by h into cos of x plus h into cos x, which is equal to limit as h tends to 0 sine h upon h into 1 upon cos of x plus h into cos x. And so if you take its limit, this is going to be 1 into 1 upon cos of x plus 0 into cos x, which is equal to 1 upon cos x into cos x, which is 1 upon cos square x, and that is equal to sec square x. So d by dx of tan x is sec square x. Okay, so whatever the number, fifth one, d by dx of tan x is equal to sec square x. You can similarly show d by dx of cot x is minus cosec square x. So now we will do the seventh one, d by dx of sec x. Okay, so I'll just take a break and I'll come to it. Okay, the next one is d by dx of sec x. So let f of x is equal to sec x, f of x plus h is equal to sec of x plus h. So dy by dx is equal to limit as h tends to 0. So I'm writing it directly, f of x plus h, which is sec of x plus h minus sec x divided by h, which is equal to limit as h tends to 0, and this is 1 upon cos x plus h minus 1 upon cos x divided by h, which is equal to limit as h tends to 0 cos x minus cos of x plus h divided by cos of x plus h into cos x divided by h. Okay, so these are some basic derivatives. That's why I'm doing it, though your textbook has solved them. So this will become equal to limit as h tends to 0, and what was here, cos x, I forgot the term. Okay. So limit as h tends to 0. This is cos c minus cos d. So you can use that formula cos c minus cos d, or you can expand. So I'll expand in this case. So cos x minus, it's cos x cos h, and it's plus over there, so it will be minus sine x sine h. Cos of anything is cos cos sine sine with opposite signs, divided by h into cos of x plus h into cos x, which is equal to limit as h tends to 0, and you can take this as cos x is common, and what you'll have is 1 minus cos h plus sine x sine h, and I'll separate the denominators. So it is h into cos of x plus h into cos x divided by h into cos of x plus h into cos x. So here cos x and cos x cancels, which is equal to limit as h tends to 0 1 minus cos h upon h square into h upon cos of x plus h plus sin x upon cos x makes it tan x divided by cos of x plus h into sin h upon h. Okay, so this will be equal to limit as h tends to 0, and this limit will be, this is part is half, this is 0 upon cos of x plus 0 plus this one is tan x as it is upon cos of x plus 0 into sin h upon h, the limit is 1. So the answer happens to be 0 plus, now this 1 upon cos x, it's basically 1 upon cos x into tan x, and that equals sec x tan x. So the derivative of sec x tan x is sec x is sec x tan x. Okay, so these are the some of the proofs. So now I'll directly go to the exercise, but there are other formulas also that you need to consider, and some of them are d by dx. The next one of course is going to be cosec x, which is equal to minus cosec x cot x. You will also have derivative of a raised to x, it's a raised to x is a raised to x log a, then derivative of e raised to x, and that is going to be e raised to x log e to the base e. So it's e raised to x into 1, which is e raised to x. Then fourth one, d by dx of log x to the base a, some other base a. The answer is 1 upon x log a. Fifth one, d by dx of log x, which is equal to 1 upon x log, and since base is not been mentioned, it is obviously e. So it will be 1 upon x log e, which is 1 upon x into 1, which is equal to 1 by x. So these are some extra formulas. So you have d by dx of x raised to n. So if I can make a list of all the formulas, some of these problems while I am solving the exercise, they will get solved. So there are some standard techniques to do them. But we will have this list, d by dx of x is equal to 1. Before that, it's gone. D by dx of a constant is equal to 0. D by dx of x is equal to 1. D by dx of x raised to n is nx raised to n minus 1. So that d by dx of x square will be equal to 2x from the above formula. D by dx of root x is equal to 1 upon 2 root x by using the same formula, this formula. Okay, then you have d by dx of 1 upon x raised to n. It can be treated as d by dx of x raised to minus n, which is equal to minus n x raised to minus n minus 1 by using that same formula, and it's minus n into x raised to minus of n plus 1, which is equal to minus n upon x raised to n plus 1. Okay, so then you have, so that's the formula for d by dx of 1 upon x raised to n. So d by dx of 1 upon x, by using this formula, you get minus 1 upon x square, right? then d by dx of sin x is equal to cos x, which we proved. D by dx of cos x is minus sin x. D by dx of tan x is equal to sec square x. Then d by dx of cot x is equal to minus cosec square x. D by dx of sec x is sec x into tan x. D by dx of cosec x is equal to minus cosec x cot x. Then d by dx of which one, a raised to x is a raised to x log a. D by dx of e raised to x is e raised to x. D by dx of log x to the base a is 1 upon x log a. D by dx of log x is equal to 1 upon x. D by dx और कौन सा बचा है? I think it's done. So the inverse trigonometric ratios, they will come next year. So I think it's done. कुछ रह गया रहेगा तो रहेगा, ठीक है? So these are the formulas. So now let's go to exercise, the first exercise. So that should be what? 30.1. So that deals with all this fundamental principle. Okay. So differentiate the following by the first principle. So I'll take the third problem first. First ka third one. So it's 1 upon x cube. So we'll say let f of x is equal to 1 upon x cube. And so f of x plus h is equal to 1 upon x plus h the whole cube. And so dy by dx is equal to, so you call this as y is equal to 1 by x cube. So this is equal to limit as h tends to 0. I'll write it directly, f of x plus h. So it is 1 upon x plus h the whole cube minus 1 upon x cube divided by h, which is equal to limit as h tends to 0, 1 upon h into, so take its LCM, it's x cube minus x plus h the whole cube divided by h, which is equal to limit as h tends to 0, 1 upon h, and this is a cube minus b cube, which is a minus b, x minus h, into a square, so it's x square minus ab plus ab, so that's plus x into x plus h minus b square, so minus x plus h the whole square, which is equal to limit as h tends to 0, 1 upon h into x and x cancels, this is minus h into x square plus x into x plus h minus x plus h the whole square. Okay, reason is a cube minus b cube is a minus b into a square plus ab plus b square, तो ये plus b square होता है, I'm sorry, plus, ठीक है? So it's there, so this h and h cancels, so this is equal to minus did I do something wrong, because derivative तो अलग आना चाहिए, हाँ I missed out this terms over here. This is into x plus h the whole cube into x cube, LCM लिया ना, so you should get this, so x plus h the whole cube into x cube. Same thing happens over here also, in the denominator there is x plus h the whole cube into x cube, and here also in the denominator it is x plus h the whole cube into x cube, and so this becomes minus, and when you take its limits it becomes x square plus x into x again, x square plus 0, plus you will get x plus h the whole square, so that's x plus 0 the whole square divided by, and remember the minus sign is for everything, divided by x plus 0 the whole cube into x cube. So that becomes equal to minus, this is x square plus x square plus x square, so it's 3x square divided by x cube into x cube, which is x raised to 6. So x square cancels, it becomes x raised to 4, which is minus 3 upon x raised to 4. Okay, so that's one problem done. Next problem, which one to do? One algebraic I'll do, and that should be which one now? x cube plus x square, इतना बड़ा कोई नहीं पूछता है, so I'll go directly with e raised to minus x. Where is my specs here? E raised to minus x, तो second का first problem, or we'll do one problem from that NCERT का first का fourth one. अरे यार हाँ, so it is let y equal to let y equal to x square plus 1 upon x equal to f of x is equal to x square plus 1 upon x. Therefore dy by dx is equal to limit as h tends to 0 f of x plus h minus f of x upon h, which is equal to limit as h tends to 0 1 upon h, and f of x plus h will become x plus h the whole square plus 1 divided by x plus h minus x square plus 1 upon x over here, and that upon h has been taken over here. Okay, so now expand this, this is equal to limit as h tends to 0 1 upon h, and this will become x into x plus h the whole square plus 1 minus x square plus 1 into x plus h divided by x plus h into x, which is equal to limit as h tends to 0 1 upon h, and this now becomes x into x square plus 2xh plus h square plus 1 minus x cube, and then this is x square h plus x plus h divided by x plus h into x, which is equal to limit as h tends to 0 1 upon h into x cube plus 2x square h plus xh square plus x minus x cube minus x square h minus x minus h divided by x plus h into x. So x cube and x cube cancels, 2x square h minus x square h becomes x square h, x h square remains as it is, and this x and minus x cancels. So you're left with is limit as h tends to 0, 1 upon h into 2x square h minus x square h. So it's x square h plus xh square minus h divided by x plus h into x. Okay, 2x square minus x square h is x square h plus xh square plus x minus x cancelled, x cube minus x cube cancelled. So left is only minus h. So I get this answer. So I can take h common. So this will be limit as h tends to 0. My problem here is not x, it is h. H upon h into x square plus x minus 1 divided by x plus h into x. So that h and h cancels. ये कुछ तो गड़बड़ लग रहा है. ओके, बाद में देख लेता हूँ आंसर. So when you take the LCM or take the limits, this becomes equal to x square plus x minus 1 upon x plus 0 into x, which is equal to x square plus x minus 1 upon x square. So is that even right? Because if I've done a mistake, I won't even know now. First ka fourth one. Okay, it looks little bit right. It is 1 minus 1 plus 1 by x minus 1 by x square. Their answer is 1 minus 1 by x square. So ये 1 by x एक extra term किधर तो जरा ज़्यादा आ रहा है. x square h x h square. हाँ, this is when you take h common, this does not remain x h square. H square ने बाहर आ रहा है, तो it's x h. And when you take its limit, it becomes x into 0. And so what you're left with is this x doesn't come, x square minus 1 by x square, which is 1 minus 1 by x square. So that is correct. Okay? So that's all actually that is there in this first principles. Now the second problem was the first one. Or I'll do that one root ka problem. Root of 2x square plus 1. F of x is equal to root of 2x square plus 1. So dy by dx is dy by dx will be equal to limit as h tends to 0 root of 2 into x plus h the whole square plus 1. It's x square only, yeah. Minus root of 2x square plus 1 divided by h, which is equal to limit as h tends to 0. इसको rationalize करना है. So I'll write the step of rationalizing directly. This will become 2 into x plus h the whole square plus 1 minus 2x square minus 1 divided by h into 1 upon root of 2 into x plus h the whole square plus 1 plus root of 2x square plus 1, which is equal to limit as h tends to 0. This is 2 times x square plus, now it is 2xh, so this will become 4xh plus h square, so it's 2h square minus, तो ये plus 1 and minus 1 cancels, minus 2x square divided by h into 1 upon root of this plus root of this. Okay. So 2x square and 2x square cancels. I can take h common and I'll get limit as h tends to 0 h into 4x plus 2h upon h into 1 upon root of plus root of. So h and h cancels. So as h tends to 0, this is 4x plus 0 into 1 upon root of. Now this will be 2 into x plus 0 the whole square plus 1 plus root of 2x square plus 1. So that becomes equal to 4x upon root of 2x square plus 1 plus root of 2x square plus 1. So that is equal to 4x upon 2 into root of 2x square plus 1. 2 ones are 2 twos are, which is equal to 2x upon root of 2x square plus 1. ठीक है? बोर हो रहा मुझे भी. कितना घंटा का हो गया ये? How many? Half an hour, 45 minutes. Another break. Okay. The next problem, and that is first problem, and that is y is equal to e raised to minus x. So y is equal to e raised to minus x. So that is your f of x. So f of x is equal to e raised to minus x. So f of x plus h is e raised to minus of x plus h. So dy by dx. Now remember, you have to call one of these functions y is equal to this. So dy by dx is equal to, by first principles. So I hope you write all those things. And so by first principles, limit as h tends to 0, f of x plus h minus f of x upon h, which is equal to limit as h tends to 0 e raised to minus of x plus h minus of e raised to minus x upon h, which is equal to limit as h tends to 0 e raised to minus x minus h. Should I take LCM in karke? That would be better off, na? Yeah. So what I'll do is I'll just make this as 1 upon e raised to x plus h minus 1 upon e raised to x upon h, which is equal to limit as h tends to 0 e raised to x minus e raised to x plus h divided by h into 1 upon e raised to x plus h into e raised to x. So I've taken the LCM and used a upon b divided by c as a upon bc. So this is equal to limit as h tends to 0 e raised to x minus e raised to x into e raised to h upon h into limit as h tends to 0, and this is 1 upon e raised to x plus h into e raised to x. Okay, so that is equal to limit as h tends to 0, you can take e raised to x common. This becomes 1 minus e raised to h divided by h into 1 upon e raised to x plus 0 into e raised to x. So this is equal to limit as h tends to 0, and this I can take minus sign out and write it as e raised to x into e raised to h minus 1 upon h into 1 upon e raised to 2x. Okay, is that done? Right. So now take its limit. So this becomes minus e raised to x into 1 into 1 upon e raised to 2x. So if I take x e raised to 2x, if I use law of indices, this becomes x minus 2x, which is minus e raised to minus x. Okay, so that's the answer. Okay, it's very simple. Just keep on using f of x plus h minus f of x upon h. जो लिमिट्स में किया वही कंसेप्ट यूज करना है and you get the answers. Okay, so b e raised to वाले सब मैं नहीं करता हूँ. I'll do maybe the fifth one, second का fifth one, and that is y is equal to x square e raised to x. Okay, this is your f of x. So dy by dx is going to be equal to limit as h tends to 0 f of x plus h minus f of x upon h, which is equal to limit as h tends to 0, and this is x plus h the whole square into e raised to x plus h minus x square into e raised to x divided by h, which is equal to limit as h tends to 0, and this is x square plus 2xh plus h square into e raised to x plus h minus x square e raised to x divided by h, which is equal to limit as h tends to 0 x square into e raised to x plus h plus 2xh into e raised to x plus h plus h square into e raised to x plus h minus x square and e raised to x. This whole thing divided by h, which is equal to limit as h tends to 0. Now I'll bring these two terms together, this one and this one, because they both have x square over there. So I'll be able to take x square common, and what is left is, in fact I can take x square e raised to x common, and what is left is e raised to h minus 1 plus this is 2xh e raised to x plus h plus this is what, h square into e raised to x plus h, and this h I will split up, so it will be h and h. So this becomes equal to, this part of the limit becomes 1, and x square e raised to x is a constant as far as h is concerned. So this limit, first limit, happens to be x square e raised to x. Here h and h cancels, and if I take its limit, it becomes plus 2x e raised to x plus 0 plus, here 1h cancels, so 1h remains, so it's 0 into e raised to x plus 0, and so the answer is x square e raised to x plus 2x e raised to x. Okay, so d by dx of x square e raised to x is this. Right. So other problems over there, you will be able to do the same procedure you have to apply. So I'll go with the second problem of the third one. Third ka second problem. Plus I think they have solved 11 problems using first principles. So you have a lot of problems that they have solved already. 11 problems. I have solved some 5 6 at least. So 20 problems, and so you should be able to do most of the work. So I'll do the second one. F of x is equal to x cos x, because that sin x we had done, not x sin x but only sin x we had done. Cos x I had not done the derivative, so अभी वो कर लेंगे, इसमें cos x में वो आ जाएगा. So so this is y is equal to f of x is equal to x cos x. So dy by dx is equal to, and so it will be equal to limit as h tends to 0 f of x plus h minus f of x upon h, which is equal to limit as h tends to 0 x plus h cos of x plus h minus x cos x divided by h, which is equal to limit as h tends to 0, and this is x cos x plus h plus h cos x plus h minus x cos x divided by h, which is equal to limit as h tends to 0. So I'll take x common and I'll have cos of x plus h minus cos x. So I'm taking the first term and the last term, and the middle term as it is h cos x plus h. And it's obvious I should split up h. So h is over here and this h is over here. H and h cancels. So this is going to be limit as x tends to 0 x into, so it is again you can use cos c minus cos d, or you can use expansion cos x cos h minus and so on. So in this problem I'll use cos c minus cos d. In the other problems I've been expanding. So one problem with cos c minus cos d. So cos plus cos is cos cos, but cos minus cos is sin sin with a negative sign. So it's minus 2 sin c plus d x plus h plus x upon 2 sin c minus d x plus h minus x upon 2, okay, divided by h. And in this is plus limit as h tends to 0 of cos of x plus upon, there's no upon, so it's done. Okay, so this becomes equal to limit as h tends to 0, and this is minus 2 sine, and the first term becomes 2x upon 2, so it's x plus h by 2, and this is x and x cancels, and so it is h by 2 sine h by 2 divided by h plus cos of x plus 0, which is equal to limit as h tends to 0 sine of x plus h by 2 with the minus sign sine h by 2, and this 2 I'm taking in the denominator, so it becomes h was there upon 2 plus cos x. So this part of the limit is 1, so it becomes minus sine x plus 0 upon 2 into 1 plus cos x. There should be one x somewhere. Yes, it is there now. X over here, and this x is there, so it's all multiplication. So this is minus x sine this, and so the final answer is minus x sine x plus cos x. Okay. Then I'll do the fourth one and the fifth one. So that I think should be the last. Other problems will manage it later on, or you might be able to do on your own also. तो देखते हैं. So sin 2x, बट वो सब sin के, इसीलिए मैं जरा what I'll do is I'll do the eighth one, third का eighth one, that is f of x is equal to root of sine of 3x plus 1, because this problem becomes a combination of the third का second and third and fourth, उसका combination बन जाता है. ओके, इट्स अ कॉम्बिनेशन है टू टर्म्स. सो जो टेक्निक इधर यूज होगा वही टेक्निक ये दोनों प्रॉब्लम्स के लिए अलग अलग यूज होगा. ठीक है. सो वी हैव एफ ऑफ एक्स प्लस एच इज इक्वल टू रूट ऑफ साइन ऑफ 3 इंटू एक्स प्लस एच प्लस 1, which is equal to root of sine of 3x plus 1 plus 3h. Okay, so that becomes this function. So dy by dx is equal to limit as h tends to 0 f of x plus h. So that's root of sine of 3x plus 1 plus 3h minus f of x root of sine of 3x plus 1 divided by h. So since it's root, we will rationalize. Limit as h tends to 0, and I am writing the rationalizing terms directly. So it's sine of 3x plus 1 plus 3h minus sine of 3x plus 1 divided by h into 1 upon root of sine of 3x plus h 1 plus h plus root of sine of 3x plus 1. So this is equal to limit as h tends to 0, and now we'll use sine minus sine. So sine c minus sine d is cos sine. Sine plus sine is sine cos. Sine minus sine is cos sine. So it is 2 times cos of 3x plus 1 plus 3h plus 3x plus 1 divided by 2 into sine of 3x plus 1 plus 3h minus 3x minus 1 upon 2 divided by h into 1 upon, so that into part I'll write on the next line, 1 upon root of sine of 3x plus 1 plus 3h plus root of sine of 3x plus 1. Okay, so that this is equal to limit as h tends to 0, 2 cos 2 times 3x plus 1 upon 2 plus 3h upon 2 into sine of 3h upon 2. 3x plus 1, 3x minus 1, they cancel, upon h. So that h I require with sine, into 1 upon, or into limit as h tends to 0, 1 upon root of sine of 3x plus 1 plus 3h plus root of sine 3x plus 1, which is equal to limit as h tends to 0, 2 cos 2 into, so yeah, this 2 and 2 cancels, 2 cos, and this is going to be 3x plus 1 plus 3h upon 2 into sine of 3h upon 2 divided by 3h upon 2 into 3 by 2 into 1 upon, now take this one's limit, root of sine 3x plus 1 plus 0 plus root of sine 3x plus 1, which is equal to, so when you take this one's limit, first term, it will be 2 into cos of 3x plus 1 plus 0 upon 2 into 1, this limit is 1, into 3 by 2 into 1 upon 2 root sine of 3x plus 1. So this 2 and this 2 cancels. So this is equal to cos of 3x plus 1, and this 3 is there, so 3 cos 3x plus 1 into 1 divided by 2 into root of sine 3x plus 1. That's the answer. Okay, so they're little lengthy problems, but that's the method you use. So I think I'll stop over here. The other problems you might be able to do. One tan का कर लेते थे, नहीं जाने दो. Tan का, they've already solved a few problems that deal with tan, so you can deal with it. कुछ और है क्या? tan square tan 2x plus 1 tan 2x root tan x sin root x cos root x tan root x tan x square minus x cos x minus 8. So nothing as such. ओके, वो लोग ने इसमें से कितना सॉल्व किया है? Not solved much, so that's fine. Should I do one more problem? Let's do that tan square x, fourth का first one, last problem. अरे यार जल्दी घूमना सर, स्क्रीन भी ना. What happened to the f of x is equal to tan square x. F of x is equal to tan square x. So this is y. So dy by dx will be equal to limit as h tends to 0 tan square x plus h minus tan square x upon h. I guess the best way would be to factorize it. So it will be limit as h tends to 0 tan of x plus h plus tan x into tan of x plus h minus tan x divided by h. See, there is no problem with this term, because if you put h is equal to 0, you get tan x plus tan x. So that's not an issue. The problem is with the tan x plus h minus tan x upon h. They give you the 0 upon 0 form. This is the one which is giving you 0 upon 0. So उसको ही handle करना है सिर्फ. So this is limit as h tends to 0 tan of x plus h plus tan x into limit as h tends to 0. Tan x plus h is actually ये derivative क्या आता है हमको पता है. This is derivative of tan x over here. Tan x plus h minus tan x. So we have derived it. इसका आंसर आता है sec square x. Okay, you can see the previous part where I have derived d by dx of tan x. So that will give you sec square x. वही same method आएगा sin of x plus h upon cos x plus h. So you pick up from there. So this answer is going to be sec square x. बचा है ये term. This is going to be tan of x plus 0 plus tan x and into sec square x. Okay, so this is equal to 2 tan x into sec square x. Okay, so I guess that's all for now. That's enough problems I've solved. So तुम्हारा एक exercise हो गया है. Other exercise we'll see now if I can do it tomorrow. ठीक है, so that's done. And अभी इसको recording stop.